Okay, so I haven't done a video for a very long time. I think I'm just gonna do it over the weekend now. Today we are gonna cover it's not very difficult, it's actually quite easy. We are going to talk about really big numbers versus really small numbers. We are going to compare them. The topic itself, really big number versus really small numbers. The topic itself is basically what we call the scientific notation. Scientific notation is a way to represent a really big number or a really small number into a decimal. Okay, it will look kind of like you have a decimal form, so you'll have 1.2 times 10 to the power of something. So the key is the multiply to the power of something. So this is like why it's with the exponents, because that's where we get to this 10 to the power of a number. So for example, this number sitting right over here is a really big number. I wish I actually have that in my bank account. So if we are talking about this number, this is actually 24 trillion. 24 trillion. I wish I have that money in my bank, but I don't. So 24 trillion is, in a regular conversation, yes, it's okay. But in math, we are quite lazy with things like this. There are so many zeros in there. We want to find a way to somehow shorten it. So we want to somehow convert this into something looking like this. So instead of 24 trillion, or we are going to talk about 24,000,000,000,000, and then another 000, that it's just not nice. So how we can do that is, if you notice, the first has to be like a decimal. How I would do it is, if you have a number like this, what I would do, the very first step is put a decimal between the first two numbers. Okay, this is for really big number. I'll put a decimal right over there. Then I'll start counting how many times I have to go all the way to the back. Okay, all the way to the end. And that is going to be my exponents. So I'll start counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So altogether there are 13 times. So I can actually represent this as 2.4 times 10 to the power of 13. Okay, it's really not that difficult. If you have a really big numbers in math, you're just going to put a decimal in the very first bit between the first two numbers, and then you start counting backwards. That's for big numbers, counting backward for big numbers. And I also want to tell you a story. It's actually, you may or you may not know. It depends on your culture. Is this image over here? If you do not know, this is actually a bank note. As you can see, there are lots of numbers over here, lots and lots of numbers. And for my culture, we believe that if you pass away and if you burn this note, somehow you'll receive the note. So, when we pay respect to our elderlies, we will always burn a lot of this, so they have money to spend. But you can see that it's a lot of money. It's a lot of money. And it's actually quite interesting. And when I think about big numbers, that's all I can remember. When I was young, I would look at this note, I was like, wow, I wish I'm not alive because I have that much money to spend. So let's say if we have this really big number. We have this really big number. Okay? Really big number. And I'm gonna use scientific notation for it. So you have this 8 over there and you have a 0. My suggestion will be, you will always put the decimal between the two numbers anyway. Always put that decimal. So you will start off with, oh my god, cannot write today. Let me remove that. I'm gonna put the 8 I will still put that dot 0 over there. Even there's nothing over there, I will put 8.0 times 10 to the power of, let's count, 1, 2, 3, 4, 5, 6, 7, 8, 9. So altogether 9 times. Alright? So, well, it doesn't matter. It's just a lot of money. If you happens to be that person in the Chinese culture. Alright, let's move on to something a little bit more difficult. So you may say, well, what if my number is look like this? 2, 7, 6, 5, 4, 3, 2, 1, 0, 1, 2, 3, 4. Like this number is not nice. This is actually a really, really big number. Maybe I should just type it out because my handwriting is pretty bad. 2, 7, 6, 5, 4, 3, 2, 1, 0, 1, 2, 3, 4. It's just a random number. I make that up. I want to turn that into scientific notation. That's what they will ask you to do. You know, turn something into a scientific notation, or assuming you can do this. The procedure is still going to be the same, but this time it may be a little bit different. So I'm still going to put the decimal in between, well over there, well over there. I'm going to put down 2.8 instead. Now the reason for that is I should be able to round this number up because I'm only taking the first 2 places for this. So I want 2.8. Okay, eventually I may tell you, you may want 3 or 3 decimal places or 2 decimal places, but in the beginning we're just gonna stick with 1 decimal place. Okay, we only want the first 2 numbers. So if I can round that up, I'll round that up. Times 10 to the power of 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. Hopefully I didn't make that mistake by counting it round. Is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so it's 2.8 times 10 to the power of 12. So you may be asked to convert a number like this. Okay, it's really not that difficult. So I'm just gonna make another one, and this time I want to show you the difference. 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, something like this. This number, this time, same thing. Put a decimal over here, 1 point. So you have to think about, can I round this up? Of course not. So it's 1.2 times 10. The rest of that is just counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so for very, very big number, it's quite simple. Put a decimal in between of the first 2 numbers, and then you are counting backwards. So that's the big number. How about for very, very small number? Small number has a different way to do it. Let's say I have 0.0000000. Okay, it's just some random things I type in. So in this scenario, you also have a really, really small number this time. Very, very small. 0.000. How many zeros are there? Like 9 zeros, 3.12. It's a very small number. So in this scenario, you are going to do kind of the same thing. You're going to find this list of number. Forget about the zeros. You're going to put the 2 numbers that are not. You put the decimal over there. Okay? You put the decimal over there. But this time, instead of going backward, you are going to go forward. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When you hit the decimal, the original decimal, you are going to stop. So altogether there are 10 times. So how can we write this out? 3 point. Can I round this up? You still have to think about that. No. So it's 3.1 times 10. Now, I want to stop right here. Do I want to put 10 over there? Think about it. No. If I put 10 over there, this will become a really, really big number. We don't want that, right? We want something very small. So instead of a positive 10, you're going to have a negative 10. So it's 3.1 times 10 to the power of negative 10. So it's a very, very small number. So in this scenario, it's a very, very small number. Let's do another one just in case. So as you can see, the small number is a little bit easier because you actually don't care about the rest of this. It doesn't really matter. It's all about the first few numbers, right? So I'm going to ignore all these zeros. I'm going to find the two numbers that are not zero, put a decimal over there. So it's 2 points. Can I round this up? Yes. So it's 2.2 times 10 is going to be a negative 1, 2, 3, 4, 5, 6, 7. So it's 2.2 times 10 to the power of negative 7. So the big number and small numbers, they are actually quite simple. So all you have to do is, if I give you a big number, I'll say convert that in scientific notation. You are going to hopefully be able to count and then be able to round something up or round something down. Okay, so this is the very first bit of this lesson. So as like before, there will be a very simple quiz on this, and then we'll move on to the next bit. Okay, good luck with the test.